O-Level Practical 2015. So we need to label our test tubes X, Y, Z, and then when we talk about adding nitric acid, it means it could be a test for carbonate ion because acid reacts with metal carbonate. So we would think that carbon dioxide gas may be produced. Therefore, we need to prepare lime water. And we have to add nitric acid until no further change is seen. This means that more than one observation can be made. So you need to watch for perhaps 2 observations when you add nitric acid. Okay, so here we are labeling the test tubes X, Y, and Z. Then we add 1 cubic centimeters of solution X into test tube X. So this is about 1 pump. We do the same for Y. So we add 1 cubic centimeters, which is about 1 pump of solution Y into test tube Y. And we do the same for solution Z into test tube Z. Now we prepare our lime water and delivery tube just in case carbon dioxide gas is produced. So we start with adding nitric acid to X until no further change is seen. So how do you know if a gas is produced? You have to look out for any bubbles or effervescence. So it seems like there is no visible change, but we have to add until no further change. Therefore, we will add nitric acid until about 1/3 of the test tube. So you can see that there is no visible change for X. So we do the same for Y. And you can feel and see that there is some effervescence. So to test for the gas produced, we need to be patient and allow more gas to be produced before we bubble it through lime water. So first observation, effervescence is seen. Once we trap most of the gas in the test tube, then we can use lime water to test. So we are adding until no further change as well. And when you look at lime water, we are looking out for white precipitate. With all gas, we have to be patient. And here you can see that white PPT is formed. Okay, next, this is done for Z. Again, there is effervescence and there is gas being produced. Therefore, we trap the gas in the test tube. And we continue to add until no further change is seen. So the first observation that we can tell is there is effervescence. So we add as well up to 1/3 of the test tube, or even slightly more. Then we bubble the gas through lime water. And this would then be the second observation, where white precipitate is formed. Okay, for the next part 2, we are supposed to add more dilute nitric acid. So by right, if at part 1 you add until there is no further changes, when you add more nitric acid into part 2, there should not be any visible change. And this time when we are adding more nitric acid, what we would like to do is to acidify the solution for an anion test. Because as you can see, the next part is to add about 1 cubic centimeters of barium nitrate solution. So therefore, adding nitric acid followed by barium nitrate, this both shows you that it is the test for an anion, which is sulfate ion. And if sulfate ion is present, that means we should see white precipitate. So take note, anion test, we need both the acid and the barium nitrate solution. So here we are doing it for test tube X, where we add more nitric acid to X until half full. So at this point, we see that there is no visible change as we are adding nitric acid. Then when you add the barium nitrate, you can see that there's white PPT and you need to shake the mixture. Next, we do it for Y. Again, we add until half full. So in this case, we should also see that there is no visible change. And then we add 1 cm cube of barium nitrate solution. And this is where you will see your white PPT. Okay, so you shake so that you see the white PPT spreads throughout the mixture. Finally, for Z, we add more nitric acid until half full again. And in this case, you can see that there is no visible change. Followed by barium nitrate. Which is about 1 pump, and you can see that there is no visible change here at all. So therefore, from these observations, we can tell the following. And how do we explain it? So we have to go by the evidence. So in all evidence, we need to have the part, the observation, and the description of the test. So for example, to find out that there is sulfate ion, it's from part A, part 2. The observation is that white PPT is formed, and the description is when acidified barium nitrate was added to X and Y. So this is how evidences should be written. Okay, for the next part, part B, when we add sodium hydroxide, this is test for cation. Until no further change is seen means we are talking about the precipitate in excess, whether it's soluble or insoluble. For the next part, where it talks about adding a further 1 cm cube of sodium hydroxide and gently heating, this is also a test for cation. In this case, we are testing for ammonium ion because there is warming. And if there is warming, ammonia gas may be produced. So therefore, we need to prepare a moist red litmus paper. And if ammonia gas is produced, the moist red litmus paper will turn blue. Okay, so because there needs to be warming, we light our Bunsen burner first. So previously it was air hole closed, now we would turn it to an open air hole. We can reduce the gas to make the fire a little smaller. So now we prepare our moist red litmus paper. Okay, and in this case, you can always choose to prepare moist blue litmus paper as well, just to see if there is any other color changes, if there's another gas that is produced. However, the key color should be moist red litmus paper. So once everything is prepared, we will now add 1 cubic centimeters of P into a test tube. This means about 1 pump. Next, we will add sodium hydroxide until no further change is seen. So we are looking for a PPT. So this PPT is green. So when we see a green PPT, we can look at the chart and we would think that an iron 2 ion could be present. So because they say until no further change, which means we want to add in excess, so what we would do is we would pour out some of this PPT so that it's much easier to see if it's soluble or insoluble. And then we'll add sodium hydroxide in excess, which means we add till about 1/3 or half a test tube. And if you look at the chart says that green PPT is insoluble in excess sodium hydroxide. So that's what we expect to see. Okay, so next they add a further 1 cubic centimeter of sodium hydroxide because now we are proceeding to test for ammonium ion. So now we would like to gently heat the test tube. So here we are expecting to see ammonia gas if ammonium ion is present. And take note, every time we are testing for a gas, we need to be patient, especially with ammonia gas, as it takes quite some time to change the color of the litmus paper, and you have to be very observant to see the change of the litmus paper, as the change may not be that obvious. So if you feel that it's starting to boil, you remove the test tube from the flame to prevent any splashing. And once you start to heat for at least 1 minute to even up to 2 to 3 minutes. You get ready your moist litmus paper. Okay, and place it at the mouth of the test tube. So you can see that we're letting the gas touch the moist litmus paper as the gas comes out of the test tube. So if you look closely enough, you can see that the moist red litmus paper has turned blue. So this test for ammonia gas does take quite a while to see the change. Okay, for the next part, what we are doing first is to dilute solution P, and then next we're adding sulfuric acid. So when we add sulfuric acid, it's either to acidify the solution, or it could even be a test for carbonate ion. So if this is the case, because of adding acid, you can always prepare lime water as well. Okay, however, when you read on, it talks about adding potassium manganate. So likely here we're talking about an oxidizing agent, and there would be a color change. Okay, and the color change for potassium manganate, it should be purple to colorless if it oxidizes the other substance in the solution. So here we are preparing the diluted solution of P by measuring 2 cubic centimeters of P into the measuring cylinder, which is about 2 palms. But you can use the measurement on the cylinder at eye level to see that it is 2 cubic centimeters. Then we need to add deionized water and make it up to 10 cubic centimeters. So once this diluted solution P is ready, we transfer it into a boiling tube. So this you can see is a colorless solution. Then next, we add 2 cubic centimeters of solution P into another clean boiling tube. We're just using 2 cubic centimeters of the diluted solution. Now we add 2 cubic centimeters of sulfuric acid. And here there is no visible change, no bubbles at all. So therefore we add potassium manganate. And you can see that the purple potassium manganate turns colorless each time it touches the solution P. So this must be a redox reaction. So the instruction says to drop potassium manganate until you get a pale pink. So we add drop by drop and we make sure that every drop of the potassium manganate has gone into the solution. So here you can see that there is some potassium manganate at the sides of the test tube. So we ensure we shake everything in and we can see that it turns pale pink. So you need to do this portion slowly. Okay, now that pale pink solution is solution Q. So we want to add 1 cm3 of solution Q and we are adding aqueous ammonia, which is a test for cation until no further change, therefore it is in excess. So we need to see if there's any precipitate produced and if it's soluble or insoluble in excess aqueous ammonia. So here we're transferring the pale pink solution Q into this test tube. Once we transfer it, it looks like it's colorless. Now we'll add aqueous ammonia. So we add a few drops first. So if you look at it closely, this PPT, based on the chart, would be a red-brown PPT. Okay, you should add more of this aqueous ammonia. Pour away some because you want to see if it's soluble or not. Okay, and add more aqueous ammonia up to 1/3 or half a test tube, at least 3 times the original amount. So with shaking, and the observation is that a red-brown PPT is formed, insoluble in excess aqueous ammonia. So with all these observations of P and Q, this would be the observations and evidences. So solution P contains iron 2 ion as well as ammonium ion, while solution Q contains iron 3 ion. Because what happened was the iron 2 ion was oxidized to become iron 3 ion. And when you see the evidences, again, there is the part of the question, there is the observation that is made, as well as the description of the test. So if we look at the ammonium ion, we have to be very clear in our evidence where we say part B, part 1, ammonia gas evolved when sodium hydroxide was added with warming as the gas turned moist red litmus paper blue.